This video is on section 3.3, measures of relative standing. So in chapter 3 so far, we've done measures of center, which kind of does some calculations regarding the data set where you can see kind of where the data lies. And then in section 3.2, we talked about measures of variation. So we could see that once you have kind of where the data is, you could see how much it varies between data points, if there's a lot of variation or not very much variation. And so here we're going to talk about measures of relative standing, which describes how one specific piece of data compares to the entire data set. So there are three different types of measures that you could use when you're discussing how one piece of data relates to the others. And the first type is the z-score, the next is the percentile, and then the third is the quartile. So first we're going to go over the z-score. The z-score is a standard score which measures how far a piece of data lies from the mean, and this is in terms of standard deviations. So z-scores are not written with a unit of measurement, and this is different than what we had before. So with measures of center, we would say that the mean, median, and mode had the same unit of measurement that the data had. When we found the standard deviation, we said the standard deviation had the same unit of measurement that the data had. This is different. A z-score does not have the same unit of measurement that the data has. It has a unit of measurement of standard deviations. So if you have a z-score of 1, that means that your data is 1 standard deviation away from the mean. If you had a z-score of negative 1.52, then that means that that piece of data is about negative 1.5 standard deviations away from the mean, and since it's negative, it would mean it's below the mean. So if you wanted to write units for these, you would say standard deviations, but most people don't. Most people just write, that it's the z-score's some number. So here's the formula that we use to calculate these. X represents your piece of data, and then X bar is the mean, S is the standard deviation. So you're finding how far away the piece of data is from the mean, and then that distance is being divided by the standard deviation to see how many of them there are. So it's just the number of standard deviations away from the mean. So the round off rule for z-scores is just 2 decimal places. Always make sure you've got 2. So there are a few things we can see. If the data value is less than the mean, the z-score is going to be negative. If the data value is greater than the mean, the z-score is going to be positive. And if the data value is equal to the mean exactly, then the z-score is going to be 0. We can also see that if the z-score is less than negative 2, or greater than positive 2, then the data value is unusual. That would mean that's referencing specifically the range rule of thumb, where we said that typical values are within 2 standard deviations of the mean. So if the z-score is a number that's larger, has a size greater than 2, so a positive 3 or a negative 3, if it's more than 2 standard deviations away from the mean, then that means it's an unusual score. It's probably an outlier. All right, so here's our example. In the 87th Academy Awards, Eddie Redmayne won Best Actor at the age of 33, and Julianne Moore won the Best Actress at the age of 54. For all the best actors, the mean age is 44.1 years with a standard deviation of 8.9 years. For all the best actresses, the mean age is 36.2 years with a standard deviation of 11.5 years. Relative to their genders, who had the more extreme age? So we're going to figure this out using z-scores. Whose z-score was a larger number, whether it be negative or positive, whose number was further from the mean. So we have the z-score is the data point, 33, minus the mean, 44.1, divided by the standard deviation, 8.9, You can see I just did that math. Okay, 33 minus 44.1 over 8.9, negative 1.25. The negative makes sense because when he won, he was younger than the mean. So he was less than the mean, which means a negative z-score. Okay, so for Julianne Moore, we have 54, and then mean of 36.2, divided by a standard deviation of 11.5. 1.55. Okay, so whose age was more extreme, whose age was further from the mean? It would be Julianne Moore. Hers was more extreme. But still between -2 and +2 for the z-scores, so still within a usual or a standard or a typical value. So would either of them be considered unusual? No, neither would be considered unusual. All right. All right, the second way that we can kind of measure the relative standing of a piece of data compared to the entire data set is to look at the percentile. So a percentile is a measure of position. It describes the location of a piece of data in the set. It does not describe its value. This is where the common errors come in when students make mistakes. So it describes the location of the data. It does not describe the value. There are 99 percentiles that divide a set of data into 100 equal parts, right? So explain the meaning behind scoring in the 78th percentile on a test. So first I'm going to say what it does not mean. So it does not mean the person scored 78% on the test in terms of accuracy. So if you got in the 78th percentile in a test, it does not mean that you got a C on the test because you had a 78% on the test. That is not what it means. It is not about the value. It is about the position in terms of all of the pieces of data. So in terms of all of the people who took the test and received scores on the test, you are in the 78th percentile. So what it does mean that of all the people who took the test, the person with the 78th percentile had a score that was higher than 78% of the people who took the test. It does mean that of all the people who took the test, whoever this person is, scored higher than 78% of them. We don't know what that score was. It could have been a 52, but it was better than 78% of them. We also know that this person who was in the 78th percentile, they scored worse than 22% of people who took the test. 22% of the people who took the test got even better than they did. So we look over here, we're going to focus more on interpretation of percentiles rather than finding percentiles and calculating them. However, if you want to convert a sample value, like some X data value, to a percentile, then here's the formula. And if you want to convert a percentile back to its sample value, then there's the formula, and here's how you can work with it. So you're welcome to use that. I know that that's kind of an interesting piece of information for some people. Okay, the third type of relative standing measurement, where you could describe how one specific piece of data compares to the entire set, is through quartiles. So quartiles are another measure. They break the data into 4 equal parts. So if you imagine you have all your data, it's lined up. You have your minimum value, you have your maximum value. The second quartile is right in the middle. It's the median that's right in the very middle. The first quartile is halfway between that, so it's the median of the lower half of the data. And the third quartile is the median of the upper half of the data. And so this is your 50th percentile, this is your 25th percentile, this is your 75th percentile. There is something called a 5-number summary of a set of data, where you find the minimum, you find the maximum, and you find the 3 quartiles, and then you just kind of write them out. And this is how you write it, with the squiggly brackets, and you just write the numbers in order. Okay, so to determine the quartiles by hand, you're just going to list all your numbers like we have in this example from smallest to biggest, and then you're going to find the median of all of the numbers. And then once you have it broken into a lower half and upper half, you're going to find the median of each of those halves. Okay, so it's not a difficult process. So that's what we're going to do with this example. You can see that we've got 20 prices for laptops shown here, and they are in ascending order. They are getting bigger. So I can see that the lower half is right here. And then the upper half is right there. Okay, so I've got them separated into lower half and upper half. And so the very largest value in the lower half is 700. The very smallest value in the upper half is 720. So quartile 2 is the middle of those pieces, or the mean of those pieces. So 700 plus 720 divided by 2, that's 710, okay? So that's quartile 2. Then we have to find the middle of the lower half, or the median of the lower half. So I'm just gonna find the middle number. It's 550 and 550, so 550 it is. That was easy. And then we're going to do the same one for the upper half. Okay, between 900 and 1,000. I'm just going to find the mean between those two values, and that would be 950. Okay, so if we were to write a 5-number summary, we would write the minimum value, 450. Then quartile 1, quartile 2, quartile 3, and then the maximum. And that's our 5-number summary. Okay, next they want us to draw a box plot, which might also be called a box and whisker plot. And so to draw that, I'm just gonna put a number line. Ooh, that's not very straight, but close enough. I'm going to draw a number line down here. So 400, 500, 600, 700, 800, 900, 1,000, 1,100, 1,200, 1,300, 1,400, 1,500, 1,600, 1,700, 1,800, 1,900. Hey, that was pretty good. Okay. I'm labeling every other line so that it's not too cramped down here. Okay. So once I've got those labeled, what I do is I put a mark for each of these. So 450, 550, a little past 700, so 710, 950, and then 1900 is way over there. Okay. And we create a rectangle using quartile 1, quartile 2, quartile 3. Okay, and then we draw, this is the part that they call the whisker, and we just show that it goes out to that minimum. And out to this maximum over here. So half of the data is below quartile 2, half of the data is above quartile 2. We know that this splits this in half, so 25% of the data, 25% of the data. We know that quartile 3 splits this in half, so this is 25% of the data and this is 25% of the data, which means that this box right here represents the middle 50% of the data. The middle 50% of the data is all right here. And then this is the lower 25% of the data. And then the upper 25% of the data is all spread out up here.